derivation of Euler's formula. Euler's formula is e to power I theta cos theta plus I sine theta, where I is root minus 1. This is a complex number. And what we can do is to say let z equals to cos theta plus I sine theta. And then we can find dz over d theta, and that equals to, if we differentiate that, that would be minus sine theta plus I cos theta. But if I is root minus 1, I squared would be root minus 1 squared. The squared would remove the root, or you could write it as minus 1 to power a half, that's the root, and then you squared that, and that would be minus 1 to power 2 times a half, 2 over 2, and that is minus 1 to power 1, and that is minus 1. So I squared is minus 1. I can see this is minus 1 sine theta. I can replace minus 1 with I squared here. I squared sine theta plus I cos theta. Let's write it properly. I taken out, so that will be cos theta plus I sine theta. We can see that z is cos theta I sine theta. That will be I z dz d theta. Separating the variables, so we've done the differentiation. Now we're going to separate the variables and integrate. dz over z equals to I d theta, and if I integrating that would be ln z equal to I theta plus c. E to power ln z would be equal to e to power I theta plus c. E to power ln z is z, and that equal to e I theta times e to power c. When theta equal to 0, put 0 here. Cos of 0 is 1. Sine of 0 is 0. So cos of 0 is 1. Sine of 0 is 0. Therefore z equals 1. When theta equal to 0, z equals 1. So if I replace here, z is 1 and theta is 0, 1 equals to e to power I0 times e to power c. And therefore, you can see that e to power 0 is 1. So 1 equals to e to power c. And if I take that back into the equation here, z equals to e to power I theta times 1. Therefore, z equals to e to power I theta. But we know what z is. Z is cos theta plus I sine theta. E to power I theta equals to cos theta plus I sine theta.